Continuing with the transformation notes, these will be the number 2 version, and they'll include rotations and dilations. We're going to plot the same points. A is negative 3, 4, B is negative 6, 1, and C is negative 1, 2. I'd like you to plot your original figure in a different color than you plot your rotated or your transformed figure, and it just helps you see it better. Now, with transformations, the one thing I won't be able to show you is actually picking up your paper and turning it, because a rotation is a turn. And that's probably the fastest and easiest way to figure out what your ordered pairs are. I will tell you that when you are making a 90-degree turn, whether it's clockwise or counterclockwise, your ordered pairs are going to flip around. So your numbers are going to reverse or flip. So your numbers will reverse or flip. What does that mean? Well, if you have negative, and let's just not even worry about the negative. If you have 3, 4, it's going to become 4, 3. If you have 6, 1, it's going to become 1, 6. And if you have 1, 2, it's going to become 2, 1. Now, you can do the signs in a couple of ways. I'm looking at the first one right now. You'll do the second one on your own. And if I rotate my paper, or if I think about how this figure is going to go, it's going to go to the right because I'm going clockwise. That's the direction the clock goes in. I'm going to end up a quarter of a turn. So 90-degree clockwise is a quarter turn. I am going to end up in quadrant 1. So this is where I'm going to end up in. It's quadrant 1. I was in quadrant 2. And my ordered pair is going to follow that pattern. So quadrant 1 is always positive, positive. So that means that all of these are going to be positive. So I'm going to have 4, 3. And again, I encourage you to actually turn your paper. It's going to help you. This is A prime. And then 1, 6. That's B prime. And then 2, 1. And that's C prime. And if you actually turn your paper, you'll see that your triangle then looks like this once you've turned your paper. All right, now we're going to go and have you do the counterclockwise. So you're going to go 90 degrees counterclockwise. That is still a quarter turn. If you go a quarter turn, that's going to put you in quadrants. You're going to fill that in. You're going to write what the ordered pair pattern is for that. And remember, when you go 90 degrees, your numbers reverse or flip around. So you go ahead and try number the second one. And this is a 90-degree counter. Counter means against, clockwise turn. And I showed a little arrows to help you. And then as soon as you're finished, turn your recording back on and check not only your picture, but your values, your coordinate values as well. So for your 90-degree counterclockwise turn, you can see that A prime is negative 4, negative 3, B prime is negative 1, negative 6, C prime is negative 2, negative 1. You went counterclockwise, which moved you into quadrant 3. The pattern in quadrant 3 for the ordered pairs is negative, negative. So in my opinion, it's easier. You know that the numbers are going to reverse, so you can see that. We're going to write that right now. So the numbers reverse, and you can see it's going to be the same as the one previous. 3, 4 becomes 4, 3. 6, 1 becomes 1, 6. 1, 2 becomes 2, 1. But then you need to follow the pattern of your quadrant. Well, quadrant 3 is negative, negative, so it's going to be negative 4, negative 3, negative 1, negative 6, negative 2, negative 1. If you look at how this is graphed and make sure that you wrote A prime, B prime, and C prime, and I actually want you to turn your paper. Actually turn your paper to the left. This is I'm showing you here, and you'll see that the figure you're looking at now is this one right here. So that's really, in my opinion, the best way to do it, but you don't always have a figure to look at. Okay, now 180-degree or half turns are a little bit different. Quarter turns, the ordered pairs reverse, or the numbers reverse. Actually, the ordered pairs don't reverse. The numbers in the ordered pairs reverse. The signs take on the pattern of whatever signing pattern the quadrant has. Okay, now we're going to do that one. Okay, we're again continuing with the points negative 3, 4, negative 6, 1, and negative 1, 2. And we're continuing with rotations, which are, the action to that is turns. So you have your A, B, and C plotted. I like you to use one color for that, and then for your transformation, I like you to use a different color. When you rotate 180 degrees, it's a half turn. So you turn once. Go ahead and use a different color. You turn once, that puts you in quadrant 1. Twice, that puts you in quadrant 3. If you go the other way, once puts you in quadrant 3, excuse me, puts you in quadrant 4. Twice puts you in quadrant 4. So it didn't matter which way you turned it, because you would end up in quadrant 4, which is why they don't tell you to go clockwise or counterclockwise. Now what you're going to see here, and again, if you turn the paper, you can actually see this phenomenon. But what you're going to see is that the ordered pairs, the order doesn't change. The numbers for the ordered pairs don't change. So 3, 4 will stay the same. 6, 1 will stay the same. And 1, 2 will stay the same. So the numbers stay the same. What does change, however, is the quadrant. So now you're going to be in quadrant 3. We know quadrant 3, I did it again, excuse me. We're going to be in quadrant 4. In quadrant 4, and we know the pattern for quadrant 4 is positive, negative. So we're going to go ahead and leave all of the x coordinates positive and change all the y ones to negatives. And so it's 3, negative 4. That's A prime. And 6, negative 1. That's B prime. And 1, negative 2 is C prime. And when you connect these, let's put it a little closer, there's C prime. When you connect the lines, there's your rotated figure. If you actually rotate the picture, it's much, much easier to see. So the numbers stay the same, and then the sign is the quadrant pattern. In this case, that quadrant pattern is in quadrant 4, so it's positive, negative. So positive x coordinates and negative y coordinates. Okay, again, for rotations, both quarter and half turns, it's really better if you actually can rotate the paper. You'll be much more successful with these. In quarter turn rotations, your numbers reverse. The x coordinate becomes the y coordinate and vice versa. However, and then the signs take on whatever the quadrant is that you end up in. In a 180-degree rotation, it doesn't matter which way you go, you'll end up in the same position, whether you go clockwise or counterclockwise. The numbers will stay the same. They don't reverse like in 90 degrees. And then again, the sign is simply the quadrant pattern. So knowing quadrant patterns is quite important. Okay, next we're moving on to dilations. Continuing on, we're now going to move into dilations. Dilations are where you enlarge proportionally or you reduce proportionally. So we have the same figure, 3, 4, negative 6, 1, and 1, negative 1, 2. We're going to start by increasing the size by a scale factor of 2. So this is going to enlarge it proportionally. It's going to be 2 times larger. And so you take your ordered pairs and you double them. So negative 3 doubled is negative 6. 4 doubled is 8. And so negative 6, 8. And frequently there will be overlap. So negative 6, 8, and that's A prime. And then you have negative 6, 1, so you're going to double negative 6, that's going to be negative 12. Now this is going to go off the graph, so negative 10 is here, 11, 12, and then you're going to double it to 2. So you have to be, just kind of have to get a good guesstimate. So that would be this point right here, this is your B prime. And then negative 1, 2. So we're going to double negative 1, it's going to become negative 2. Oops, let's go ahead and write this. Negative 6 doubled was negative 12, or times 2, and 1 doubled is 2. So negative 12, 2 is right there. And then negative 1 doubled is negative 2, and 2 doubled is 4, so negative 2, 4 is C prime. So negative 2, 4. So you get a little bit of overlap on C prime. And from here to here, from here to here. And then the key to this is that it's proportional. So you can see that you've enlarged the figure proportionally. Now, when you only go off a graph a little bit, it's fine. I'm going to show you one additional one where we actually go off the graph a considerable amount, and you have to actually change your scale on your graph. Your intervals can't be by 1. You're going to go by 2s or by 3s. We'll decide that when we get there. Okay, now this one's going to be reduced proportionally. Again, you're going to get some overlap more than likely. And so the first thing that you want to do is you're going to reduce this by a scale factor of 1/2. Taking something by a scale factor of 1/2 is like dividing by 2. And so we've got negative 3 divided by 2. Well, that doesn't come out evenly, so negative 3 over 2, which is negative 1 1/2. And then 4 divided by 2 is 2, so it's negative 1 1/2, so negative 3/2, negative 1 1/2, 2. Okay, that's going to be your A prime. And then we've got negative 6 divided by 2 is negative 3. Or half of 6, negative 6 is negative 3. Half of 1 is 0.5 or 1/2. So half of 1 is 1/2. So negative 3, 1/2. That's B prime. And then C prime is half of negative 1 is negative 1/2. And then half of 2 is 1. So negative 1/2, 1. So negative 1/2, 1. And that's going to be C prime. There you go. There's proportionally, it's still the same shape, so these are similar figures. One more time, your figures are similar, so similar figures have proportional sides and congruent angles. You aren't told anything about the angles, but you just need to know if you have a similar figure, they'll have proportional sides and congruent angles. Same with these. These are similar figures. And similar figures, one more time, have proportional sides. We know that because we took it by a scale factor of 2, and then we took it by a scale factor of 1/2. And they also have congruent angles. You can't see that, but in fact that is the case. Now, I'm going to do one more where you actually go off the graph and you have to make the graph you have to go by a different scale factor than 1. So we're going to do that next one. Okay, we are going by a scale factor of 4, so I'm going to go by 4s on the graph, because otherwise I'm not going to be able to fit this graph on here. So we're going to go ahead and go by 4s. So I'll go ahead and graph. Okay, so I've crossed out the scales that were there, and I've gone by 4s, 4, 8, 4, 8, negative 4, negative 8, negative 4, negative 8. So it's going to be a really tiny, the original thing's going to be really tiny. So negative 3, so you go, if this is 4, you're just going to, here's negative 3, and then you're going to go up 4 right there. There's A. And then if you go negative 6, well, that's going to be just, there's 4 right there, and then go another middle. That's going to give you negative 6 and 1. That's going to just barely be right there. And then C is negative 1, so negative 1 is going to be right about here, and then 2 is going to be right about in the middle. So that's A, B, C. See how small the figure is. Now we're going to be going by 4s on both axes, and so we're going to take everything by 4. So negative 3 times 4 is negative 12. 4 times 4 is 16. So negative 12, 16. So it's going to go negative 4, negative 8, negative 12, and that's going to go 4, 8, 12, 16. So that's going to be right there, and that's going to be our A prime. And then we've got B, so negative 6. We're going to take that times 4, so it's going to be negative 24. And then we're going to take 1 times 4, so 4. So negative 24, negative 4, negative 8, negative 12, negative 16, negative 20, negative 24, and then 4. That's going to be our B prime. Now our C prime is also going to be by 4. So we've got negative 1 times 4 is negative 4. 2 times 4 is positive 8. So negative 4, 8, there's your C prime. So by just changing the scale, you're able to fit it all on here.